Right, so once we have connected the data converter to the tablet PC via the USB, we can proceed to connect our hydraulic connections to the hand pump and the data connection to the data converter as well. Right? So for the data converter, just connect it like that, follow the red dots, push it in, and then we can switch it on over here. Yeah, just one press of the button. And for our hydraulic hose, it's just the quick plug, so we just press it like that and lock it. So now we can move on to connect our assembly onto the valves, over here. So to do that, we use the column bracket. It's made of aluminium here. So if the valve body is big enough, you can just simply place it on top like this. If there's a situation where the valve body is not big enough, right? For example, like this, the valve body is not big enough to support it. We can always use collars. So we have a step collar here and the threaded collar. So the step collar goes on top like this to support the column bracket. Or if it's a threaded collar, the threaded collar goes it's tightened to the column bracket and then it fits nicely on top of the body. So once we have placed the column bracket on top, we can then go on to connect the coupling. So since this is a M16 thread, we can use the M16 coupling. So we just remove the M8. And then we screw it in. And make sure there's a minimum of 5 turns when it's screwed in. There you go. Make sure it's secure. And after that, we can proceed to insert the coupling to connect with our centerlink rod. Make sure it's concentric, and then the same thing, 5 threads. Make sure it's secure. The next step is to insert our sensor, displacement sensor. So first of all, we need to screw in our sensor bracket. So when it's at this angle, you want to tighten the nail nut first. And then once you have done that, loosen it to allow easy access for the displacement sensor. Loosen the screw, insert, and then we tighten using the sensor. So to set our displacement sensor, we just need to press it down and then lock using the adjusting screw. So the next step is for us to choose our range of load cell to use, and we can do that by using tab and then clicking on test. Okay. So there's two parameters that we need to fill in before we can get the data for the valve, the particular valve. So user company and device number. But the device number is normally on the valve itself. So for this valve, it's A2. Right. So once these two parameters are filled, so automatically we can find all the other data by just clicking autofill. So so now there is all these informations, and the most important information or fields we need to take note of is the seal diameter, the set pressure, required set pressure, and also our working pressure. So in this case, there is no working pressure at the moment since it's offline. There's no working pressure, there's no inline pressure. So our work pressure is 0. Right? Our seal diameter is 70 as indicated by the valve. So this is the data that has already been measured. So we can use this seal diameter. And then for this valve, our required set pressure is 2 megapascal. So once we have these three data, work pressure, required set pressure, and seal diameter, our estimated force will automatically be calculated for us, and hence we can choose our load cell. So for the load, so in this case, our estimated force is 784. So we choose a range that is higher than that, which is 2000 kg. So you want to choose the 2000 kg load cell. So we place it to the centerling rod. And then insert the load cell platen and then screw it in all the way. So once it's screwed in, we want to make sure we want to loosen it one round to allow compensation for pumping. So just half a round maybe. Then after that, we can insert our power cables for the sensor. So we have a load cell power cable, which is the black one. So we just insert it, connect the red dots together, and then push it in. Same goes for the sensor data cables. Just push it in like that. And then we have the hydraulic hose connection, which connects to the hydraulic cylinder. So you wanna push it in and then lock the nut over here. So now once we have done the assembly, we want to test our valves. So at this page, once we have filled in all the parameters, just press test. And then the first thing to note is the range of load cell sensor. You want to make sure it's the correct range being used. So you can see that 2000 is the correct one that we are using. And then the next thing to do is to press start test. And then when we press start test, we will notice that the live force of the load cell sensor is now 0. Right? So there's no force acting on the load cell sensor. and then we see our live displacement is 9.45. So this is our sensor setting at the moment, the one that we set earlier. Right, so in the first test, the first thing to do is press to 0, right? And then we want to lock our hydraulic pump. So just tighten the knob here, and then we can start pumping. Right? So we want to make sure we pump stably. And notice that as it's approaching the yellow line, and as soon as it reaches the yellow line, the displacement sensor will reset to 0. There you go. So it resets to 0, and the valve is, the system is telling us that the sensor is getting ready for the valve to open. So we pump slowly, steadily until the valve opens. And when the valve opens, there will be notice this horizontal line over here at the red line, and that is as I am pumping. So as I keep pumping, when there is a horizontal line, it means that the valve is already open. And when this box appears over here, it means that movement sensor value exceeds set threshold value. That means the sensor has already reached its threshold value of 0.1, and hence it gives us the reading of the live force. So before we do anything, we just release the pressure in the system. Just release it, and then we continue to press OK. So our set pressure, right, as calculated, is 1.998, and this is by using the live pressure over here, the live pressure at the opening point of the valve, and also our work pressure and our seal diameter values, our sealing area values. So it is according to this formula over here. It shows that set pressure is equals to work pressure plus lifting force over sealing area. So after we got our first test result, we can proceed to do it another 2 times just to get an average value. So same thing, start test. We don't have to click press to 0 for the second and third test, and then lock it again, and then we start. Make sure it hits 0, right, and then we can continue our test. So once that box appears, just loosen the pressure in the system, press OK, and then the second test results will be shown here, and then the average as well. Okay? And then continue for the test for one last time. So start test, lock the pressure, pump, release the pressure, and press OK. So what we notice here is there's 3 identical values, and then the error rate is negative 0.1%. So if it's within divergence of 3%, it's fine. And error rate means the amount of divergence from its original required set pressure, which was what we inserted earlier as 2 megapascals. Right? So once we have done this and we have got an average and we are satisfied with the error rate, we can proceed to click complete. With this to generate our report. So complete, and then if there's change in work pressure, we can input it, or if there's no change, we just press no change. Okay. So we'll go back to the main page, and then we go on to click on number 3, which is generate report. So click on it, and then the latest test that we have done will always be on the top, which is number 1. So you can go ahead and click on it to see our data. So we have the required set pressure here as inputted in the system, work pressure 0, and then we have our seal diameter, and then we have all this information of the test. There's 3 times test and our average, and then we have to what we need to do is to input 3 of these fields, which is the test medium, this production date, and the pressure range. So the pressure range is following the PN of the valve, which is in this case our set pressure was 1.98, and then the PN of the valve is 2.5, so 25 bar, so 2.5 megapascal. Production date is for this valve can be obtained the nameplate here. So production date here is 2022-09, September 2022. So we just fill that in, 2009. And then we have a test medium. So in the test medium, since it's offline, so you can just put it as air. And we scroll all the way down, and then we have this general explanation. Check if everything is correct, and then you can proceed to create report. So we return to our main page, and then we click on number 4, which is report search. So the report that we generated the latest report that we generated will be shown as number 1. So click on it. Right, so this is our safety valve test report. So the recommended calibration for each valve is 1 year. So from today, 4th of July, and then for the next one is 3rd of July 2024. So it's 1 year from today. And we also have all the graphs from the test earlier, the standard that we follow, and also all this information, the information of the valve will be shown in this report as well. And this is customizable, right? So you can change your customer info, and then in the future we'll have a company logo, so we can insert the company logo there as well. And then if we want to print this out, so we can just export, and then you can just insert a thumb drive to export the file. And so you can just insert a thumb drive here, and then you can just export the file just like any Windows 10 or Windows 11. Right, so that's it for our testing process, our assembly and testing process. So So it takes roughly about 10 minutes to complete the assembly and free test and to generate the report. And the good thing about this is it saves time and it's very reliable, and also it's very lightweight because all our products all our components in this whole assembly are very light, so it saves a lot of energy in that sense as well. Right, so thank you guys.